Hello, everyone. Good morning, good afternoon, or good evening, wherever you are. Welcome in this webinar, and thank you in the first place for giving you your most precious resource to us, that is your time to learn what we have been doing in the last couple of months. Welcome, everyone. Just a small confirmation, is sound okay on your side? Put it in the chat box if that's the case. I'm watching, and sound is confirmed to be good. So we are ready to get started. And I actually want to start this webinar with a story. It is a real story. It happened for me last Friday when I was at an event where there were several people from other companies in other businesses. And as a kind of introduction, we had to present ourselves to the other people in the room. And of course, when I was in my position to present myself, I explained that I was doing software development. And the reaction of most people who were not software developers was a little bit like, oh, okay, you are the one that we do not understand. And immediately I heard frustration with other people about software development. One of the people there owned a printing company, and the statement that he made was, oh, I'm always asking software developers if they then can implement this or that, and then they come with the updated software, and then it does not really work exactly the way I was thinking, that I was expecting. And he said to me, why, Bruno, why is this always happening? And the answer that I gave him was, well, I have good news for you. AI will enormously help you to get more done with your software, also to get things done that the programmers did not exactly program for you. Because when you, at this moment, ask in your software to implement function A, you will get function A and not function B. With AI, the possibilities will multiply, and you will be able to achieve way more with your software than what was specifically programmed in your software. That as an introduction to this webinar, because what I'm going to show today is exactly that, how we can integrate AI in Delphi applications. And so that is what we are going to cover, how we can integrate it, how we can take advantage of it, and as such make our applications much more rich in functionality than we ever programmed. We are also going to cover how you can build AI agents and how you can use these agents and set up agentic flows from your Delphi apps, create these things with Delphi yourself. What we are not going to cover in this webinar is generating Delphi code by AI, or how AI can help you to develop your code. So that's not covered today. If you attended this webinar for this purpose, then I would say goodbye and see you another time. But for those who are interested to add AI functionality on top of the functions in your applications, then you're, of course, in the right place in this webinar. So the content for today, it will start with showing how you can use and take advantage of LLMs in your Delphi applications. Then we are going to a more complex level, and it is function calling from LLMs, functions that will be handled by your Delphi code. We'll introduce you to the MCP concept for building AI agents. We will also show you how you can, with our upcoming tools, easily build MCP servers from your Delphi IDE. We'll also show you how you can have actually MCP server functionality also embedded in visual Delphi applications, existing Delphi applications that you extend with MCP server functionality, and will also cover how you can build an MCP client yourself. And finally, we'll conclude with the availability of the tools that we have been working on in the past couple of months. But first of all, let's focus on taking advantage of LLMs via REST APIs in your Delphi applications. And here are the logos of the 8 LLMs that so far we are covering. I'm not sure if every one of you recognizes these logos. If you recognize these logos, put them in the chat box. I'm curious of how many of these logos are recognized by you. I'm waiting a little bit to see what's happening in the chat box. So this logo, for example, okay, I'm seeing Olama, I'm seeing ChatGPT, I'm seeing Mistral, Perplexity, I see Claude and DeepSeek. I think one is left that is not covered here, Gemini, of course. So from left to right, we have OpenAI, ChatGPT, we have Gemini, Grok, we have DeepSeek, Claude, Perplexity, Olama, and Mistral. And that is what we are covering today with the FNC Cloud Pack, with the Cloud AI component that is integrated in it. And basically, the functionality of using such an LLM via the REST API comes down to sending text context from different roles. In other words, the prompt that you send to the REST API, and in response, you receive content. For example, if you ask the ChatGPT to translate something, to summarize something, to provide you information on whatsoever, you will receive that textual response. And how to get this set up? Well, everything starts typically from requesting an API key from the LLM service that you want to use. If we go back to this slide, Olama is actually the only one of the 8 LLMs that you can locally install on your own machine, and as such does not require an API key. The others are hosted in the cloud, and these require an API key to start using them. So on these specific LLM websites, you can request such an API key, and that gets you started to use the LLM via the REST API. Most of these cloud-hosted LLMs also allow you to select the model. Most also have multiple models that you can select from. And then basically you set up the context of your question to the LLM, and optionally also some information in the system and assistant role. We'll cover that in a moment. And with this, you perform an HTTPS post request and you get the response of the LLM via text. And this is an example, a code snippet that shows you how you can use our FNC Cloud Pack AI component, which abstracts all these 8 LLMs. So with just one property here, the service property, you can select what cloud LLM service you want to use. Here in this case, Claude from Anthropic. And you specify the key in the API keys property. You select the model, or you can choose the default model if you don't specify it. And then you provide the context. Here in this case, it is a question: what is a powerful development tool for creating native Windows applications with RAD components-based visual approach? And you can also specify a system role, so that's an additional context for the position in which the LLM places itself for answering your question. And in this case, we provide this context as you are an IT expert, should be, and execute the request. And then you will get a response from the LLM. So with our AI component, we abstracted at this moment 8 of these LLM services. And that means that with the same code, you can choose what LLM to access. You can even use it to compare the responses of different LLMs. And of course, we are very curious to hear what additional cloud LLMs you would want to see us covering in future updates. We thought that we start with already very important ones, but they are growing by day. So if you see other interesting LLMs, be sure to contact us and we'll look at also abstracting these in one component. And here is then a typical response that you get from the LLM. And now let's go to the topic on top of that, and that is using LLMs with function calling. So here we are going a step forward from simply sending questions or context and getting answers information. Here we are going to augment the LLM with function calling to get the LLM to call other functions to get live data and actually decorate the responses from the LLM with live data. How does that actually work? Well, that is here summarized in this scheme. So everything starts with the user sending a prompt to the LLM. And in the LLM, it tries to recognize whether there are functions needed to properly answer the prompt. And for this, the LLM was already informed with all the possible functions, and that is in the terminology of LLM's tools. So it was informed with the tools or functions that are available to the LLM. And so from the prompt, it will identify what function will be needed to be called to get the right answers to embed that in the response of the LLM. So first step is to identify the required function. And when it is properly identified, it will perform a call with parameters to this function. Actually, this call is something that the LLM returns. So it returns JSON that has all the information for allowing the application to call that specific function and passing the parameters to that function. And that function is supposed to return a response. And that response is then retrieved by or sent back to the LLM and incorporated in the final output that the LLM sends back to the user. And so here is how, with the Cloud AI component, you can take advantage of function calling. We try to make it very simple, as always with Delphi, of course. Simple, fast, straightforward. So what you do is in the FNC AI component, you have the tools collection where you can add tools to. Each tool represents functions. And so here we implemented a function to get the actual weather and some specific city. So the description of the function, that is important because it is the LLM that, with the help of the description, will identify that this tool is the tool that is needed to embed the additional information in its response. And here we have also one parameter to this function. We will, of course, need to pass the city for getting the weather, and that's the one parameter used here. And with the tool comes also the execution of the tool. So when the LLM judges that it will need to call that tool, our FNC Cloud AI component will receive that request from the LLM and will, in response, trigger the execute tool event, and it passes the arguments that the LLM provides to this execute tool handler. And here you can see the expected argument is, of course, the city. We perform a request to get the weather for that city, and we return the result. And the result is sent back to the LLM, and the LLM provides its final answer, augmented with this additional information, the actual live weather information. So enough talked. Let's go to our first batch of demos that I prepared for this webinar. And maybe I'll quickly go over the chat box to see if there is any question already coming up that requires some attention. And here I see a question: are we able to use specific properties, functions of a specific LLM? So we actually tried to abstract all the LLMs covered so far, meaning that with such an abstraction, of course, it is the same functionality for the same LLMs, with the same component for different LLMs, but we plan actually to also expose additional functionality that is only available in specific LLMs. OpenAI comes to mind, as OpenAI offers, in addition to chat completion, REST APIs, several more very interesting API. The Assistant API comes to mind, the Whisper API comes to mind, and this is not generally available in other LLMs, and for sure it will be interesting to also expose access to these specific OpenAI functions. No more questions for now, so let's move actually to our first demo. I want to inform that everything that you see, you can already do with the FNC Cloud Pack update that we released today. And this set of demos is also included in this latest release. And first of all, I want to inform that we have actually a specific encrypted storage for your API keys that will be used with all the other demos, and an application with which you can create this encrypted storage of your API keys. So if you run this application, you will be able to set the API keys for the different LLMs that we support. And when you perform save, it creates a encrypted file containing these keys, and all of our demos are actually loading the keys from this file. I also explained that different LLMs have support for different models, and what we also have available is an application with which you can check the available models. So here, with this sample application for Claude, you can see here all the models that Claude provides. We have already preset in our component the model that is used by default, and that's typically the latest model that is available. So these are the Grok models. If you go to OpenAPI, you can see how many models are at this time already available. With our component, it is default configured to the GPT-4o model. And then let's go to the first simple usage of LLMs with the REST API. And here we have the typical prompt and response example. So here we are actually selecting the LLM, and we have a prompt, a question, and we send it to the LLM and just await its response. Meanwhile, that I'm waiting for the Mistral response, you can see here the response from Mistral, and you can see, of course, that Delphi is also included in this answer. What I'm seeing in the chat box is the question for analysis of PDF files. And actually, that will also be coming, but that is limited to specific LLMs. OpenAI is one of them. OpenAI can handle that. Gemini is another one that can do that, but that is not going through the completion API or chat API. That is going, in the case of OpenAI, through the assistant API. And we will also cover that in our Cloud AI component. Not in this first version, but it's already implemented to some degree, and you will receive that soon with that assistant API available. If we look at the code of this example, you see the FNC Cloud AI component. And what is actually happening here, you can see that we initialize the API keys from this encrypted key configuration file. We get all the supported LLMs via the get services call and fill the combo box with the services. And then here we grab the context, the prompt that we want to send to the LLM from the memo, and we execute the call to the Cloud AI component. And in response, the unexecuted event is triggered. And when that was a successful response, in other words, the HTTP status code is 200, then we fill the second memo with the response. It is as simple as that. So let's move on to the second example, and that is the example with function calling. So if we have a look at the code, it's pretty much the same in terms of configuration and setup. We load the keys from the same file, we initialize the combo box, and in addition, what we did is we have in this Cloud AI component, we have a tools collection. And you can see that we added actually one tool in this collection, and this is the get weather tool. And if we look at the parameters, that's again a collection, because of course you can have multiple parameters. And if we look at the parameter, here it is the parameter name is city, the description is city, and the type of this parameter is a string. You can see that you have different types to choose from. And actually, if you have an array, you can also define the type of the parameters in this array. So here you can specify again for all the elements in the array what type it will be. But here in this case, it is very simple. We have the get weather function. Here is the description of the function, and it's thanks to this description that the LLM knows that this can be that this will be the function to use to get the weather for a specific city. And that's the final thing to do is the execution. So when the LLM judges that it needs this function to be called, this event is triggered. And here we call the method to get the weather with the parameter that we get from the arguments with the name city. And get weather is implemented here in this code. This is also actually via a free REST API that we get that weather. The first thing that we need to do is actually get the longitude and the geo coordinates for this city. So we use the free Nomatim OpenStreet API to get the longitude and latitude, and then there is also a free API to get the weather, the current weather at some specific location, longitude and latitude, and this is the call to that API, from where we get the weather information, the current weather information, and we grab the temperature and the wind speed at this location. And as you can see, we return the response as a JSON object containing the temperature and the wind speed. So let's run this example, and how I can use it is actually very simple. I can add the city here, like Tokyo, and we execute it, and we now use the Claude LLM. And here you see that it detected, the first step, it detected that it needs function calling, and it called our function and got the weather for Tokyo, current temperature and current wind speed. If I would, for example, change this and ask this for Brussels, Amsterdam, and Luxembourg, the AI, and let's switch, for example, to OpenAI, it should detect now that I'm having 3 cities, so it needs to call my function 3 times, and so indeed it successfully retrieved these weather conditions, current weather conditions, and returned them in its response. And so that shows you how simple it is to implement functions and have these functions called when appropriate by the different LLMs. And I'm going to have a look at the chat box to see if there are any further questions. I see if that is only an FNC component or a VCL component. Well, the magic of an FNC component is that it can be used in VCL applications and in FireMonkey applications. So with FNC, you can use them everywhere. It's not really needed to have a separate VCL component of that. Actually, what I'm showing here is in a VCL application. What I'm going to show next is in a FireMonkey application. So I'm mixing the types of applications here in the demos. Another question that I see is, do we add each prompt answer when calling the LLM again, or is there some mechanism to help? Well, actually, when the function gets called, the event of the tool is triggered. You return the response via the result of this tool event that is triggered, and it is the Cloud AI component itself that sends the answer back to the LLM, and then the LLM picks up that answer and will embed that answer in its final response, and then the final response is actually returned to the application here in the Cloud AI on-executed event, where, in case everything went well, status is 200, the response is set in the second memo. So all the specifics of detecting what functions the LLM wants to call and getting the responses from these function calls and sending it back to the LLM to get the final answer, all of that is handled automatically for you from the FNC Cloud AI component. All right. I see no more questions relevant to the demos that I'm going through at this moment. So let's move to the third example, and that is actually the integration of function calling with visual components. So what we have here is, again, the Cloud AI component. That is the component that does all the magic. And here I have, again, a couple of tools added. In this case, I have a tool added, a function to clear all markers on the map. And I have also a tool to add a marker to a specific location on the map. As you can see, the description is what helps the LLM to identify that this is the tool to be called. Clear the markers on the map is what the LLM should normally understand, and also add a marker on the map add a specific longitude and latitude coordinate, and also include a title. If we look at the parameters for this function, you can see that we have three parameters. That is the longitude, which is a number, the latitude, of course, also a number, and the title to add to that marker, which will be a string. In this example, I have also included actually programmatically a tool that got added. So here you can see that I programmatically add the tool, and that is a tool to add a label on the map, actually add a label with information about the weather on the map. And you can see that programmatically I also define here the parameters for that specific function. So that includes the longitude, the latitude, and the actual weather at that specific location. And I'm reusing the function to actually get the current weather. So that is done with the get weather function call with this description for this function. And in the tools execution, so we have tool executions for clearing the markers on the map. By the way, this is the map is the FNC maps component that is using or is configured for using the free leaflet maps. And so what we do here is clear the markers. When we have the second tool execute to add a marker on the map, here I'm getting the three parameters that were passed, the longitude, latitude, and title, and I'm setting this marker at this coordinate with this specific title. And then I remember that I also programmatically added the tool to add labels on the map. And here I specified actually, if we have a look here, the parameter is actually an array of labels. So that means that this function can be called with multiple parameters at once in an array. And this array consists of objects, and each object actually is an object that consists of longitude, latitude, and weather. So that enables us to have just one function call where it can add multiple labels at multiple coordinates. And you can see here the handler for this specific function call. Here it will get that array of labels via the labels parameter, and here it loops through that array and adds labels at these specific conditions with a red color font and a yellow background. So enough for the code. Let's run this example and see what happens. And so the first thing that I'm going to do, we are going to use, let's say, we can use DeepSeek, I think, for, although here actually is a nice thing to see differences in LLMs. If we use, for example, Gemini and execute this request, you can see here I need the latitude and longitude of each capital city in Europe. So Gemini by itself is not smart enough to figure out where these capital cities in Europe are. And that, contrary to, for example, OpenAI, when we execute that, and let's now zoom out a little bit and go to Europe. It is now getting these capital cities, and as you can see, it completed the request. So all capital cities in Europe have been marked on the map. So that means that OpenAI is smart enough to know the specific coordinates of capital cities in Europe. Actually, Claude is also able to do that. But Gemini, for example, is at this moment not able to do that. Maybe by choosing another model, it will be able to do so, to be checked. But that at least already shows you differences in capabilities of different LLMs. And let's now invoke a function to get the weather at specific locations. So what we are going to do is give the weather, or better, show a label with the current weather on the map for the cities. And actually, I'm going to add the city where our office is, and nearby is Bruges, and also nearby is a city at the coastline. And let's see what OpenAI is doing. So now it should actually detect, and you can see already the result here, it should detect indeed that it needs to call the temperature, the weather conditions for Wevelgem, Brugge, and Knokke. And it will include that in labels on the map. If we zoom in a little bit, now it's better. You can see that our office is located here in Belgium. Bruges, historical, fantastic city, is located here. You can see that it's already a little bit colder as it's more nearby the coastline. And here, Knokke is actually at the coast, and it's colder there, of course. That was kind of expected, but it shows you the capabilities of function calling and handling that in visual controls. And I created another example with visual controls, and that is integration with a chart. I used the FNC chart for that. And here, the request that I'm creating is, can you make a bar chart of the population of the 10 biggest countries in Europe? And let's ask this to Claude, for example, and see what it is coming up with. It is reflecting at this moment. And here we go. It used the FNC chart to do that. Another test that we can do is, for example, create a pie chart having the distribution of the 7 most popular drinks in Europe. And let's ask this to OpenAI and execute that and see what it comes up with. And here we see that coffee seems to be the most popular one. Tea, beer is also among that. Wine is also here. And let's now maybe compare that with the USA. I execute it again. And here we go. And we see actually for the USA that coffee, soft drinks are popular. Surprisingly, water is missing here, so I'm not sure. Here is bottled water. Indeed, it has 10% in the USA. So how we did that? Pretty much in the same way. We have the tools collection, and here we have tools to clear the series, to add a bar series, to add a byte series, and to add a point. So that is the functions that we give to the LLM, and the LLM figures out what functions to call. If we go to the implementation of the execution of the adding the bar series, you can see here that it will add in the FNC chart a series of the type bar chart, here of the type pie chart. And here is the execution of adding a point to the chart. And you can see here that it gets the value and the title as a parameter, and it adds a point in the chart for that value, and it also adds the associated title with it. So that is actually how you can mix our visual controls with responses from LLMs. I'm, before going to the next demo, going over the chat to see more questions. What if the prompt is in a different language? The tool descriptions with it, what happens? So that is actually a good question. And I think with AI, there's so much happening that it never gets out of interesting things. So let's bring up a question that I will ask in Dutch, which is my native language. And let me figure out a question. Probably most of you will not understand what I'm requesting here. I will translate it in a moment. So that is my question in Dutch. I'm curious myself to see what the tool will do with it. Actually, what I ask is give a distribution of the sales of the 5 most well-known European car manufacturers. And as you can see, it answered in Dutch. It was smart enough to pick up the functions with English descriptions. And you can see that in Europe, the most popular car is Volkswagen, Audi, Toyota, BMW, and of course also Mercedes-Benz. So that's my answer to your question, that also other languages are of course possible to use with the LLM. Let me go to the other questions. How reproducible are LLM actions, especially for smaller LLMs? It is always something to consider, but I tend to believe that when you use a local LLM like Olama, for example, and your LLM is the same, that the reproducibility is quite high. That is actually my experience. Actually, also while working on these demos, you will understand that I sent the same questions multiple times, and I saw actually a pretty good reproducibility with the different LLMs that I have been using. Other question that I see, can we be sent the sample projects after the webinar? Actually, all the samples that I'm showing in this part, the webinar is far from finished. There's another set of samples are included now in the latest version of TMS FNC Cloud Pack version 3.4. So if you get that latest version, you will have all the samples included here. Another question, can 2 charts be created, one for Europe and one for the USA in one window? With some small extension to this demo, I actually do not see much problem in doing that. And then, is it possible to train a prompt in ChatGPT to read several documents and then use Delphi to ask questions from this document base? I will show you actually in a moment what you already can do today with, in this case, images. I explained at the beginning of this webinar that, for example, OpenAI also has the Assistance API where you can give the assistant multiple PDF files, for example, or other files, and then perform queries based on the information of the files provided. The Assistance API is the next thing that we will have coming up or added in the FNC Cloud Pack. We are still in R&D phase right now with that part, so expect that very soon. So let's move to the next example. I see some of you are already impatient to see how you can actually use the power of AI to get rid of knowing all these syntaxes of SQL commands, and where you can use natural language to query for data in your data set. So what do we have here? We have a ADO for the sake of simplicity of distributing that example. And what we have in the cloud AI components, let me have a look. We have a couple of tools. What we have is a tool that will retrieve the field names that are available in my data set. So that has no parameters, of course. It will just return the fields, and let's have a look. Can be interesting to see that implementation. Here you can see, actually it gets it, it could have retrieved it from the data set, but it retrieved it from the columns in my data grid. And you see here that it returns the field names as a comma separate list of field names, and that's sufficient for the LLM to get working with that. And the other tool that I have provided, the second one, is set a SQL select command. So that is the function call that will happen when the LLM has come up with the SQL statement it thinks to use, and actually perform that, call that function to perform that, and have it executed on the data set. And so let's run this example. And what we have here is a simple table of different airplanes that have been built throughout the years. So they have been built from a specific year to a specific year and in a specific country. So you can see different countries, for example. And so the question that, or the prompt that I created is, I want all planes that are not from the United States and built before 1970. So that's my natural language to get the LLM to come up with the appropriate SQL select command for getting that information from my table. And so here is actually the response from the LLM. It generated select star from planes where country does not equal United States and year start is smaller than 1970 and order it by year start. That is actually something that I did not add in my prompt, that I expected some kind of ordering, but Claude decided to do this himself. So actually, that is how you can now integrate natural language to perform queries on data in your applications. I see another question here. Is it possible to use my Firebird database with ChatGPT? Yes, this is the answer. I will show you also a demo later in this webinar. And it might be good to block the SQL drop command, of course, and that is highly recommended to block that command, to not execute that command. Actually, the command execution that you see here is the execute for that specific tool or function, and you can see here that it gets the SQL command from the parameter SQL. It sets it to the ADO query SQL property, and then it activates the data set again. All right, another example, and this time something a little bit different. Here I'm going to demonstrate how different LLMs can today already deal with images. So what we do here is ask the LLM. We will ask in this demo two things: to describe what it sees in a picture, and as we have the capability to specify two images, we will also ask the LLM to give its own information to compare to pictures. So how that is accomplished, actually, if we look here we are not using tools. We are actually, this is not based on function calling. This is actually based on adding additional information with the prompt, so non-textual information that we add with the prompt, here in this case a image, You can also add text files, for example, but that is the concept. So here we add an image and we add text to our prompt, describe the picture. The other one will basically add two files to the prompt, and it will ask the question, compare the two pictures and describe the difference. And execution is always the same. In the unexecuted event, it will actually fill our FNC Rich editor with the response that it receives, if, of course, it is successful. Important to mark here is that the default models of all the LLMs do not support images out of the box. That's why we had to specify a couple of different models for different LLMs to ensure that these models can deal with images. The OpenAI model, for example, the 4.0 model actually can deal with images out of the box, but the Gemini, regular Gemini 2.0 model could not. We have to specify a specific model that can handle it. So let's run this application and let's pick a picture. And here in my folder, I have a typical medieval painting. And let's ask, maybe in the first place, let's pick Gemini to describe what it sees in this picture. And here you can see that it thinks it is a still life painting featuring a variety of objects. So it actually sees the bottle of champagne it thinks it is. I think it's rather a bottle of wine. Yeah, that is the full description of what Google Gemini actually is thinking about this picture. We can choose another model. Let's see what OpenAI thinks about this picture and see what it comes up with. Same thing, it's a classic still life featuring a variety of objects. It also thinks actually it's a bottle of champagne. Maybe it could be, I'm not sure if Jules Mum could be a brand of champagne. And it sees apples, oranges, walnuts, and knife. So that's actually pretty good. So let's now have a look what it can do with different images. So I prepared two pictures with quite some similarities, and let's see what we get when we ask the LLM to compare these two pictures. So first of all, I'm asking OpenAI what it thinks about these two pictures. And here you can see it sees different models of Mercedes-Benz. And it gives some information about the door style, front design, body shape, etc. Actually, quite disappointing for someone who is a Mercedes passionate. And let's ask, therefore, another model to compare these two pictures. And let's see what it comes up with. I see in the chat box actually that mum is champagne, so the model was smarter than I am and answered it correct. I was in the first place thinking about wine. And here we ask Claude to compare these two images. And as you can see, this is, as a Mercedes passionate person, quite more accurate. It shows on the left side the Mercedes-Benz SLS AMG and the Mercedes-Benz SLR McLaren, even with some nice additional information when these cars were produced. So that is actually pretty good. And then I want to show you also some, let's say, special detail about LLMs. Here we have what I would consider a picture a little bit on the edge, but I think that picture would still pass, for example, on Instagram, as it does not really show, let's say, the essential parts. And let's ask Claude to describe this picture. And here you can see that it apologizes but cannot provide a description. Let's ask OpenAI what it thinks about this picture. And it also feels sorry but cannot help with that. I'm not sure if Gemini can come up with an answer. Okay, Gemini is actually a little bit more liberal and can answer that. And also Mistral, our European hosted LLM, will actually have no hesitation to provide a description for that image. But here you see how LLMs are actually also programmed to avoid certain things. I leave it up to your own interpretation what to think about that. All right, let's move to another demo. Okay, and here it's also using the LLM with images. And here, same technique, adding the image as a file to the context and then the prompt message. The prompt here in this case is extract the text from that picture, and the setup is pretty much the same. We are also using the vision models of these three LLMs, and let's see what comes up with that. And for this example, I created a picture myself from a famous Delphi book, and that is actually an essential Delphi book, Delphi component designed by Danny Thorpe. And let's see what the LLM can do with performing an OCR on the text of this cover. And it is thinking at this moment, and here is what it comes up with. And actually, that is, I would say, a little bit disappointing. If we choose OpenAI and ask OpenAI to come up with the text that it thinks there is on the back of this book, it is processing. Okay, and you can see that OpenAI actually gets the text completely up to the details here in the right corner of the text, the price, etc., the number, everything is correct. So it is quite amazing actually what OpenAI can do in terms of OCR. And then the last example in this part of the webinar is about text processing. And the difference here is that the file that we add for the LLM is a text file. So no longer an image file, but a text file. And let's see this demo in action. I also prepared a text, and I found a little article online about vibe coding, the hype of these days, the vibe coders. And so what I'm asking here is to summarize that text for me in one paragraph. And so that is the paragraph that Claude comes up with. Let's ask DeepSeek, for example, if it can translate that to German. And it is reflecting, working on that answer. Still working. From time to time, DeepSeek can take some time to come up with answers. This time it takes quite a long time. Okay, but it managed to give me the translation to the German language of the text that I provided. So that example shows you how you can also perform all kinds of text processing with the LLM through the Cloud AI component. And now I want to move to the second part of this webinar, which is about MCPs. MCP, that is stands for Model Context Protocol. It is something that was launched by Anthropic, the company that provides Claude, and you can consider it as a standardized way to let people build predefined sets of tools, functions to augment what an LLM can do. It is so a protocol that standardizes how the LLM discovers the functions, tools, and can also execute these tools. So, and that goes through an MCP client, the MCP client itself that communicates with the LLM. And you can configure multiple tools, multiple collections as such of specific functions that you want to augment the LLM with. How that works, is summarized in this scheme. And here you can see the MCP client and the MCP server. The MCP client will be communicating with the LLM. And in the first initialization phase, actually, the MCP client is responsible for launching, loading the MCP server or servers. And in that initialization, it will actually ask the MCP server what kind of tools do you provide, and it will manage that collection of tools provided by one or multiple MCP servers. When then the user creates a request, for example, what's the weather in San Francisco? The LLM will recognize the need for external information as it does not know the current weather in a city, and it will turn to the MCP client. In this case, it will hand over the task to the MCP client. First of all, asking what tools, functions do you have available? When it discovers that there is a matching available function, it will ask the user the permission to execute that request to the MCP server. So the user is in control, decides what can happen. And so when the user accepts that the MCP server is called, it is the MCP client that will do the function calling to the MCP server. MCP server is programmed to handle that function and will do whatever is needed to do. For example, call a REST API to get that current weather, but that can also be getting access to a local file on the system, for example, or getting data from a database. It will return the requested data. It will be sent back to the MCP client, which will provide it to the LLM, and the LLM will offer the final answer to the user. So that's the flow that is happening when MCP is involved with the LLM. So at this moment, there are already a large number of existing MCP clients. Everything started with Claude. But meanwhile, there are other popular MCP clients. I'm not sure if some of you can recognize the logos here of the other MCP clients. Put it in the chat box if you recognize these logos. I'm curious. Let's see who comes up with right answers in the chat box. Actually, if you scan the QR code, you can find a website that lists all available clients at this moment, and you can also scan the code for a list dictionary of all kinds of MCP servers that are available for you. I see actually no one coming up with answers for the logos, so I will bring up the answers here. There is a cursor that is a forked version of Visual Studio Code. Klein is the same, also a forked version of Visual Studio Code. Visual Studio Code itself got MCP support a couple of weeks ago, I believe. There's also Windsurf, also a fork of Visual Studio Code that was actually acquired by OpenAI a couple of, I think it was days or maybe 2 weeks ago, something like that. And the fantastic news is that your Delphi MCP client is what you could build already today with the tools that we provide. So how? Let's first start with the MCP servers. How do you create an MCP server today? That is, to begin with, a command line server application. And in that server application, you actually create an MCP server that comes by default with a couple of settings: the name of your server, the version of your server, and then actually you here under server tools add tool. That is actually the place where you will add your own tools that your MCP server will be handling. And here is the implementation of the add tool function. It returns an MCP tool, and remember, it's very similar to the LLM function calling, but here embedded in a separate server. You see the same concepts. There is the name of the tool, there is the description of what the tool is doing, what kind of result that it returns, and also the parameters that this tool expects, in this case, a simple name of a city. And then, of course, there is also the handler. So the function that gets called when your tool is chosen by the MCP client to be executed. And so this handler takes in the arguments of the type t value. So it can be any kind of value that is passed as an argument. And here, what we do is extract the first parameter, the city, as a string, call the weather API, and return the results. And so let's now show that the concept of MCP client servers and clients that we can build also from Delphi. Let's close everything. Don't need to save anything, and let's open the group of MCP servers and clients. So what we have is a package that gives you the MCP server. So that is the component that allows you to do that. We have a package to let you build MCP clients. That is a application that is a bridge between an MCP client. It's actually an MCP server bridge that sits between an MCP client and a visual Delphi application. And here we have a demo that takes advantage of that. And the first thing that I wanted to show you is actually the weather demo as an MCP server. So it's a command line application, same function to get the weather, so that's not interesting. But here you can see creation of the MCP server, and here you can see the configuration of the tool with the description of the tool, and then the tool that gets added to the server. And here is execution of the tool with getting the weather. Actually, this is configured as an MCP server in the Claude. And actually, I should, to let everything work properly, I should first run that application. And when you play with Claude, you will find yourself removing it regularly via the task manager, because when you simply close Claude, it will not always fully close. That's why I'm doing it this way. Okay, here is Claude, and under its configuration as developer, you can see the different MCP servers that are installed. You can see the basic demo, database demo, the bridge, and also a Spotify MCP server. And so if now I'm switching to Claude and I ask, what is the weather today in Miami? Let's see what Claude is doing. I'm not sure. Okay. And if you see this box, actually, this means that it detected that it needs a tool. And so it will execute that tool. So that is here our weather MCP server. It will execute it and pass the parameter Miami, and this is the response that was sent back from our MCP server, and you can see that it embedded this information in the response. So with this configured MCP server to get the weather, we can use that from the Claude Desktop AI tool. Let's move to our next demo, which is also a command line application. Let's check the source code. And actually what we have implemented here is a gateway, an MCP server that is a gateway to any FireDeck database, and implementing a couple of tools. So tools to let you run a SQL query to get the list of tables, table information, create tables, delete tables. So anything that you typically do with a database. Here is some information that it comes up with. And actually what I did here, if we go to File, Settings, Developer, and the configuration for my MCP client from Claude is here. Here you can see this is the MCP server for the database, and you can see here that with these parameters I connected to a sample SQLite database. So let's close that again, and let's see when Claude decides to get to use that MCP server. So I'm going to invoke a command, give a list of tables in my database. And so it should detect now, indeed, it performs a request to our MCP server. And here you can see that it retrieved the following tables in my SQLite database. And I can go further, like list the artists in the playlist, or better, in the artists table. And let's see what it comes up with. So here you see it performs a SQL command, and that is the result that it returned. And it found out there are 275. The Claude desktop tool decided to show you the first 15. If you would change the request and ask more, it will for sure give you more. And then let's see if we can use the bridge to have our visual tool available. Maybe first I need to cover some details on that. Okay, and let's deal with the MCP bridge. So, as I showed you, the MCP servers, the weather one and the database one, are command line tools. So the question comes up, what if we want external AI control of our visual Delphi applications? Well, That is something that you can also do with a bridge that we created. So basically we have a command line bridge MCP server that communicates to our visual application and actually passes all the commands from the MCP server bridge to our visual Delphi application. It is executed, handled there, and the responses are returned to the MCP client from where this bridge server is executed. And so I will show you how that is created. If we go here in this one, this is the form of our visual application, and you can see here two non-visual components, the MCP server and the MCP named pipe transport. The named pipe transport is the communication to the bridge MCP server, and here you see the actual MCP server where you will find again the tools. And here you see that we added two tools. That is one tool to get the code from the editor and the other tool to set the code in this editor. This is a syntax highlighting editor that we added in this visual application. This visual application is running here. And let's see if Claude can do something with that. Create a Delphi base 64 encoding function taking a byte array as argument and add this code to my editor. That's what I'm asking from Claude, and here you can see the code that it comes up with, that it generates. And let's see if it can also perform the final step. And as you can see, it has added this code in my Delphi visual application through that MCP server command. It gets even more impressive if, for example, I do the following: get the code from my editor and add an XML comment on top of the code describing the functionality of the code. And let's see what Claude comes up with. So normally what we expect is that it will perform the first function call to get the code from my editor, and then it should interpret this code and come up with a description of this code, and then it should put back this result in my editor. And so as you can see here, this is the description that it created and added on top of the code as I requested from my here from my Claude desktop tool. And okay, that's where we are at this moment. So this shows you all the possibilities of creating your own MCP server, be it command line, be it extend your existing visual applications with MCP server functionality through a bridge. And let's now move to the last topic of this webinar, which is about the MCP client. So the MCP client is what sits between the LLM and any application. That includes your own Delphi MCP servers that you create, but also many of the third-party MCP servers. And that means that you can start with AI, start to mix functionality of your own MCP servers with third-party MCP servers. The MCP client is what we created and allows you to create such a client with minimum effort. And the client will actually communicate, of course, with an LLM. That's where the AI is actually. And you can select what LLM you will be using from that MCP client. For example, the Claude desktop tool will always use the Claude AI. Here with this MCP client, you can choose for yourself what AI you will be using in your MCP client. So let's show how this works. Here we have the client demo. We have the main form of that application. Here you can see the client application. You can see that we can choose the LLM that will be used in this client demo. And let's have a look at here we show you how you can configure in the MCP client what service you will be using. We actually added the MCP client to the data module. And this is the MCP client component. And so you drop that on the form and you basically configure what LLM will be used, for example. Let's run the demo. It will become clear what that is doing. So this is our demo. And if we go to settings, well, what we have is the API keys for the different LLMs that can be used. And here we have configured the different servers. So this is the same configuration as we did in Claude. So the database MCP server we created ourselves, the weather server, the bridge, and we also introduced here a third-party MCP server, which is a server to work with Spotify. So Spotify has an API, and someone else created an MCP server that can call these Spotify APIs from your LLM. Here you can actually see the tools that this MCP server for Spotify provides. You can also see here the tools that we provide in our database MCP server. And so in this client, if for example, but I will need to do one thing first, and that is authorize this MCP server for Spotify, I will need to authorize it to use my Spotify account. And here is my Spotify account. So let's see when, for example, I ask via the MCP client, show me the Spotify playlists that I have. So now it should detect I need that Spotify MCP server and perform the request to get the playlists. And here you can see what it retrieved as playlists that I have. If you are in doubt, you will for sure recognize information like, for example, let's see here, these are playlists. There's this one that you recognize. So for sure, these are playlists that are in my Spotify account. And now let's do the final, I think, nice demonstration. And let's see if hopefully everything is successful. Nice demonstration of the power of mixing different MCP servers to let your LLM work with it and do things, do things for you that otherwise would take a lot of effort to do. So I'm now going to access via our own MCP client our database MCP server. Show the playlists in my database. So in our SQLite database, there's also a table that contains playlists. And it is requesting that. And here you can see the different playlists that are in my SQLite database. And now I'm going to ask, show the tracks in the grunge playlist. So now it performs the necessary requests to get this information from the playlists table, and actually that table contains linked or joined tables with artists and records. And what I'm going to ask now, let's see if this will hopefully all work out nicely. Add this grunge playlist from my database to my Spotify account. Let it work and see what is happening. Let's see if it can also do that successful today. It's still thinking, working. It will need to perform in the back multiple calls. So what it says is the grunge playlist has been successfully added to your Spotify account. So maybe let's see if I can find that, if it will. Okay, and here we see indeed it was not there a couple of moments before, but you can see actually the playlist that it added from my SQLite database locally on my machine. So that shows you the enormous possibilities that are created by combining multiple MCP servers and getting new functionality you never thought possible before. And that's it for the demos that I created for this webinar today. And to summarize everything that you have seen, the first part with the FNC Cloud AI component is already available. You can start working on it now. It is on your account if you have an active license, and you can start playing it. The demos that I showed in this webinar are included. So that's for part one. Part two is the part for creating your own MCP servers and clients. And that is at this moment an alpha version. We target it for Delphi 12 at this moment, and we make it available for all active all access users at this moment. This will be offered as the TMS AI Studio. And at this moment, it still requires the FNC Cloud Pack, where the AI LLM is. But in the future, that will be standalone, available, everything nicely embedded in the AI Studio. So if you want to get started playing with MCP servers, MCP clients, sign up for getting access to that alpha version for Delphi 12. We provide you a download. That download actually also includes all the demos that I have been showing here today. And here is actually the QR code to the landing page where you can register for getting access to that MCP server, MCP client, AI Studio distribution, and get playing with it. And of course, we very much look forward to all your feedback. This is things that we have been working on the past months. There are so many more possibilities, and the AI scene is changing almost every day. So, of course, for sure, you will see other possibilities that we haven't covered or seen yet, and that we are excited to work on. So send us your suggestions, feature requests, or ideas for future extensions, future integrations of AI. We will be very eager, and very excited to work on all that. Any other things in connection with AI, we specifically created an email address for that, ai@tmssoftware.com, and let's exchange in this extremely exciting area of software development that we have. I'm going over the chat box to see if I missed maybe some questions so that I can handle these. Will this webinar be available as a video to watch later? I expect it is being recorded. I expect the recording will be fine. So the answer should be yes. What is the use case for using an MCP over just using the FNC component? I think if you create the power of creating an MCP server is that you can expose functionality in your own Delphi applications, Delphi specific functionality. If you want to expose that in connection, certainly as I showed you with the Spotify example, in connection and mix it with other MCP servers to let the AI do things you never imagined before that could be automatically done by combining multiple MCP servers and getting things done by natural language commands to these tools. That's the thing that I can think of. That, of course, for example, give it access to your internal data, to databases, all these kind of things. I think can add very valuable functionality to your Delphi toolset. And so I see already a couple of things answered by my colleague Bradley, and that's, I think, an ideal moment to also express my deepest thanks to the entire TMS team, who, of course, have been feverishly working on this in the past couple of months. I'm thinking about Bradley in the first place, Tunde in the first place, and also Peter Bart, who have been supporting and the FNC tools that are created for this. It was, of course, and it is, and it stays a big team effort to come up with such results. So a big thank you and shout out to the team. What more questions do we have? Let me see. I see a question from Patrick, actually the Spirit of Delphi winner 2024. Patrick in France. Now let's manage home by voice in Delphi. And actually that is something that we are also eager to bring shortly. OpenAI has the Whisper API endpoint that is able to recognize voice and convert speech to text. And that should actually help us to create voice-driven functions that you can execute in your Delphi application. So very, very exciting to work on. And I'm actually eager to get that done to also show you that side. I'm meanwhile a little bit tired and bored of having to type all these prompts. Why simply not ask my application and have OpenAI and the LLM do all the work for me? So that's maybe for one of the next webinars coming up. Another question that I see here: could the data be sent to a grid using the MCP? Sure, that can be done. We actually already created some test applications with our FNC data grid, where we created an MCP server with a couple of tools to access cells in our grid. And so with that, you actually expose the FNC data grid to LLMs and let the LLMs do what it thinks to do with that grid, get data from it, put data in it. You could actually add a tool that performs a sort in that grid, and the LLM, when it judges that it needs sorting, it should execute that tool and have the grid sort the data. Okay, let's see what more questions we have coming up. Here I have a question. We just want to know where FNC came from. FNC is actually something that we created way back time goes fast, in 2017. And it was the time where we wanted and tried to create components that could be used in VCL applications and the same code base that these could be used in FireMonkey applications, so that on our side we only had to write code once, and on your side, the user side of components, you purchase one set of components and you can use them wherever you want to use them. And as this type of components is actually neutral to frameworks, we call this FNC, and it stands for Framework Neutral Components. So in short, if you want a component that you can use everywhere, FNC is what you look for. Note also that we have not covered it today, but FNC controls like the maps, the chart, etc., can also be used in web client applications created with web core. So that's yet another target for our FNC components. And with that, I think I'm through most of the questions. Detailed examples of using MCP in a local environment to automate normal operations would be interesting. Indeed, the samples that we created, the weather sample is a kind of beginner's sample. Then we have the database MCP server demo that works with FireDeck, and as such, makes all FireDeck supported databases MCP server accessible for you. There are open source MCP servers written in other languages. For example, the Spotify MCP server was written in JavaScript and runs on Node.js. There are also MCP servers, open source, JavaScript, Node, that do local file access. We did not yet want to duplicate all this functionality, but it could be easily done with your favorite Delphi language, of course. And that is something that maybe in the future we will also add demos like that in the package. Another question that I see is, can that be used in mobile apps? There is actually FNC Cloud component can be used cross-platform, so any target of FireMonkey can be used. So you can integrate that. I see no limitations in that to integrate it in an iOS or an Android application. With respect to MCP, at this moment we have MCP clients that typically run on desktop. So there is the Cloud desktop tool. For example, Visual Studio Code has MCP support that also runs in the desktop on Windows, Mac, and Linux. So that is the area where typically MCP is used. I have personally not yet seen the MCP concept on mobile devices. Not sure if that is something that is coming up. I'm not sure if maybe there are some technical limitations, yes or no, remains to be seen. But with the Cloud AI component, I think you can already enhance and enrich the functionality also in your mobile applications a lot. Another question is, any timeline for when this will be ready for general release? Good question. Now we start the testing phase, so we are eagerly waiting your feedback, and when everything proves to be robust, stable, then we are looking to make the step towards a release. Realistically spoken, we want to give this at least a month of your testing before we are going to release that. So let's think positively, and by summer we should have a release. We will all have Hey Google, Hey Siri. And we are looking forward to Hey Bruno. I'm not sure we will use that word, but interesting idea. Let's see. Maybe I think we should make it Hey Delphi, do this for me. I think that would be wonderful. Something to think about, something to work on. And then another question, can MCP be used to understand how the program works and interact with the user? That's an interesting question. I think RTTY could be the answer to your question, but we are still researching that area to make, let's say, automatic functions based on RTTY, automatic MCP servers based on RTTY available for you. Not yet a definitive answer, because between that and the actual implementation lies some further R&D work to do here for that. All right, that was the Q&A. If there are no more questions, then I want to thank you for being here. I hope you enjoyed it, and I'm very much looking forward to all your feedback. AI@tmssoftware.com. Remember to register here. Scan this QR code to register for getting our first test version and get updates to that test version, so that you can play with these things for yourself. And let's grow this together to fantastic tools that will enrich your Delphi applications. If there are no more questions, then I thank you very much for your valuable time, for being here. Again, I thank the team for this amazing team effort, creating these amazing results. Stay tuned. We'll continue to communicate via our YouTube channel as well. So if you watch this via YouTube, subscribe for more content, watch our blog for more content, and let us know what you think about it and in what future directions we should take these things. For now, thanks a lot for all being here, and until the next time. Bye-bye.